Alright, so I've been asked to formally write down how we convert a given signal where we know the time span into an RPM. So just as an example, we'll just say we've got some signal here. And we can readily see, better put that in view here. We can readily see we've got a signal. Now whether you measure it from the top or the bottom, it's going to be the same. So we've got this signal and we know the time it takes from peak to peak. And what we're asking is to convert that milliseconds into an RPM. So let's just say for our example here, we have 40 milliseconds and we're asked to convert that into an RPM. Right, so 40 milliseconds, and that would be one revolution. So we could say one revolution over 40 milliseconds. Now I know a lot of you have just been given a number, and in this case you'll see it'll be 60,000 divided by this 40 millisecond in this example, and you'll get the RPM. Now that's fine and dandy until you forget 60,000, and then you don't know how that number came into being. So it's kind of a poor way of doing things. So this is the formal write-up of how you would do this and how we came to this 60,000 to begin with. So understand, I can multiply this fraction right here by 1 as many times as I want, and I'm still going to have the same fraction. But what we need to do, and that's what we're going to do, but what we need to do is convert this milliseconds into a minute. Now our revolution or cycle, it's all the same thing, that's already correct. So we need to walk this milliseconds toward minutes. So if there's a millisecond on the bottom, to cross that out, we need to put one on the top. So we're just going to multiply a fraction that equals 1, but we're going to put a millisecond up here so we can just cancel them. So how be we put 1,000 milliseconds? Now what does 1,000 milliseconds equal? Well, it can equal 1 second. Right, and then you'll notice we cross off our milliseconds and we're just left with some numbers, but at this point in time, which revolutions per second, we want revolutions per minute. So we just multiplied by 1 again, but we need to dump this second, which means we need to put a seconds in here. So how about we do 60 seconds, and we know we're going for a minute. 60 seconds equals 1 minute. All right, and then we cross out the seconds and we're left with revolutions per minute, and that's what we want. So we simply multiply 1 times 1,000 times 60. That's where you got your 60,000 from. 40 times 1 times 1 is 40. And doing the math, it's 1,500 RPM. Now, the choice of numbers you use up here doesn't matter as long as you're multiplying it by 1. So I'll give you an example of what I mean, and you'll see how it doesn't matter. So let's stick with this 40 revolutions, or sorry, this 1 revolution in 40 milliseconds. So that signal from point to point is 40 milliseconds. What if we just decided to say, hey, why don't we do 500 milliseconds? Okay, so we're going to end up crossing these milliseconds off. In seconds, how much is 500 milliseconds? Hopefully you all understand it's a half a second. All right, let's do it again. We got to do something here. Let's call it 30 seconds. 30 seconds is a half a minute. Will this still work? So we got seconds, so we're down to revolutions per minute again. 1 times 500 times 30 is 15,000. 40 times 1/2 times 1/2 is 10. And sure enough, 1,500 RPM again.